All right, just making sure I'm on. So 16.3. All right. This is where it starts to get a little bit intense. Now, I say that, but really this stuff that we've gone over before but it was back in Physics 1 when we did vector addition. So if you didn't like vector addition, then you will probably cringe a little bit on this stuff. Sorry. You know, I can see your faces almost even as I say that. It's kind of funny. All right, so you can see that we've got a negative charge and then we've got two positive charges. And it's giving you their charges. It's saying that charge 1 is 1.2 microcoulombs. And it's basically the origin, so it's 0, 0. Q2 is considered to be negative 0.6 microcoulombs. And it's 0.5 in the y direction and 1.2 meters in the x direction. And then the Q3 is positive 0.2 microcoulombs. So it says, what's the force on charge 2 due to the other two charges? Well, think about what's happening here. This is a negative charge, and these two are positive charges. So, you know, they're obviously going to be attracted to that negative charge, and they're both pulling on it. Okay, so that, you know, that affects it basically. So let's just look at this one for a minute. Okay, so we've got this force right here pulling on each other. And then you've got this happening right here. So it's going straight down. Remember that head to tail method situation? So we have something like that, and then you do the resultant vector. Okay, so that's what we're end up having to find once to figure out the force on Q2 due to both of those forces on it. So we're basically looking for this value right here. Okay. All right. So we've got to fill in some stuff. Now, this really isn't bad because this is just going straight down, and we know that the distance is 0.5. This distance is at an angle, so we've got to figure out what the distance is there. Okay, so go over to the next slide. Hopefully you guys can print these. If not, you know, definitely be writing this down. So we've got the distance of 1 to 2 is what we're trying to find. So charge 1 because of charge 2. Okay, so we've got, we know the distance between R1 and 3. Okay, we know that distance. We know that distance is 1.2 meters. And we know the distance in the y direction too. We know 2 to 3. Okay, so how can we find this? We've got this distance and we've got this distance. How do we find this one? You guys know this, even if you're sitting there not thinking you know it. You have A, B, and C. So the Pythagorean. So you could do A squared plus B squared is equal to C squared, essentially. All right, so now let's plug some numbers in. We've got 1.2 meters squared plus 0.5 meters squared. Do the square root of that, and you should get 1.3 meters. Okay, now, how do we find the force? All right, so we've got to do the force on both situations. So first, let's just do the force of 2, charge 2 and charge 1. All right, so how do we do that? We have to use that Coulomb's law equation. So K times Q1, Q2 over R squared. All right, so plug in some numbers. What is K? K is 8.99 times 10 to the 9th Newton meter squared per Coulomb squared. Times charge 1, so charge 1 is 1.2 micro, so -6 And then the is it the second one that was, yeah, charge 2 is 0.6. There we go. 0.6 times 10 to the negative 6 coulombs. Okay. Divided by that distance, so this 1.3 meters squared. All right, so you do the math of that, you should get 3.83 times 10 to the negative third newtons. Or you could say 3.83 millinewtons. Okay, because negative 3 is milli. All right, so that's not all. Okay, that's just for this one. That's for this situation between charge 1 and charge 2. Now we've got to figure out the situation between charge 2 and charge 3. All right, so that one's not as hard because we don't have to do any kind of Pythagorean because it's just going in the y direction. So we do the same equation here. So we have 8.99 times 10 to the 9th Newton meter squared per coulomb squared, and multiply that by 1.2. I'm sorry, no, not, yeah, 1.2, yeah, times 10 to the negative 6 coulombs, because that's charge 1. Wait, no, I did that wrong again. I'm sorry. Let me erase that really quick. Yeah, we're doing not charge 1, we're doing charge 2 and 3. Okay, so charge 2, let me look back over. Oh no. No. Oh, crap. Okay, I'm so sorry. I have to take that off because I can't keep it. So charge 2 is 0.6 and charge 3 is 0.2. Hopefully you guys had that written down. If not, you can rewind through this video. I really don't want to restart the video. Okay, so let's go on and we'll do force 2 to 3. Alright, so we have 8.99 times 10 to the 9th Newton meter squared per coulomb squared times 0.2 times 10 to the negative 6 times that 0.6 times 10 to the negative 6. And by the way, those are coulombs. Divided by your distance, which was just 0.5 meters squared. And you should get 4.32 millinewtons that time. Okay, so on the first one, I'm going to rewrite that really quick, just that you had 3.83 millinewtons. Okay, so you have these two forces happening. Now, this guy right here is just in the y direction because that's this right here. That's that force right there. This one right here has both x and y components. Okay, so do you remember whenever we did vector addition, we had to break them up into both y and x components, right? So we can figure out what the angle is based on this y over x situation. All right, so if we do the inverse tangent of the y, which is 0.5 over x, then we get 22.6. Well, why do I do that? Because I've got to end up getting the basically the sum of the x component and the y component. So I've got to get, I've got to do the cosine of the angle for the x component, and then the sine for the y component. Hopefully that stuff's sort of ringing a bell. So you do this, You got to use this one because this one had both x and y components. So you do 3.83 times 10 to the negative third because it was millinewtons. So newtons cosine 22.6, which is negative 3.53. Okay. Why is it negative? Well, let's look at this really quick. Let's say that this was the origin right here. See how this is going in the negative x and it's also going in the negative y direction? So we give it this negative 3.53 millinewton. And then you've got 3.83 times 10 to the negative third newtons sine 22.6. And I said it was negative as well. Okay? So now we got to do the sum of the x's and y's. So this was the force in the x direction. This is force in the y direction. And that was all for that guy right there. What about this guy? That guy was just in the y direction. Okay, so keep that in mind. So we have to figure out the total force. So the whole force, right? So we got to do the square root of force in the x's squared plus the force of the y squared. All right, so we got to do the square root of the force of the x's. Well, there was only one x value, right? It was this one right here. So you've got negative 3.53 millinewtons squared. Plus, you have your y values now. So you had this one, which was negative 1.47 millinewtons, plus, and you have this one. Now, going back to our picture really quick, if this was our origin right here, this is down, right? This guy is looking down. So, or it's pulling down. So that's a negative y. Okay, so you've got plus negative 4.32 millinewtons. All right. And that's also squared. So when you do the math of that, you should get 6.8 millinewtons. Okay? And if you would take the inverse tangent, okay, of your y values, which is this added together, so basically negative 5.79 millinewtons, divided by your x value, which is negative 3.53, okay, you should get that it's 58.6 degrees south of east. Okay, so when I drew that picture before, I said it was like going like this, and then you had that charge 1 to 2, and then charge 2 to 3, and then you're finding that force. Okay, that force right there is that number. This angle right here, if this was your coordinate system, this angle right here is 58.6 degrees. Okay? So, well, and it's really like this. Sorry. So, I know that's kind of a lot just for one example. But we're going to do more. So, try to stay calm.